Good afternoon, everybody. Is it loud enough? Okay. Thank you very much for inviting me here and for giving me the opportunity to put faces to names, because I knew a lot of names of people in this community, but I could never figure out who they were, and today is a good opportunity. The title of my presentation is Open Access Spam for Ghana, Challenges and Opportunities. And before we can talk about the challenges and opportunities, I have to say a few things. First of all, why Ghana? Because this is the immediate cooperation we are having with Geoshare. No, it doesn't do. First, before I can speak about challenges and opportunities, I want to mention the following points. What is spam? The spam process, visualization and downscaling, the results of spam, the equations behind spam, which is very important, the crop list and the statistical data coverage for spam, and finally, what are the challenges and what are the opportunities. Spam. You have heard of spam. You have heard of the computer spam. You have heard of Hormel spam. But we are not talking of neither of these. We are talking about the spatial production allocation model, and the name comes from the same author as the horrendogram or the horses for courses. What is spam? Drawing on a variety of inputs, spam uses an entropy-based data fusion approach to plausibly assess cropping system distribution and performance at mesogridded scale, meaning at 5-minute pixel globally, or maybe at 30-second pixels at country level, depending on the data you have. And the variety of inputs are primarily national and subnational production statistics, meaning area and yield, and therefore also production. Then the production systems in the country, the distribution of them, rural population density, cropland extent, irrigation, crop suitability, existing crop distribution maps, which lead into the validation of the product, and crop prices. In a graphical representation, spam starts with subnational data, which is at a coarse, very, very coarse resolution, adds pixelized layers, converts them, or creates priors for each of the production systems, feeds the whole thing into the model, which is a GAMS model, and comes up with the pixelized area. And you can see from a very even distribution of this crop area in the whole admin unit, it can pinpoint where the crop is plausibly grown. And spam does this for 42 crops simultaneously. Before this can take place, there have to be behind-the-scenes adjustments and calculations. And we start with the subnational crop areas, which are our fixed value. And from there, we go adjusting in a pre-process to make sure that the irrigated land, the sum of all the irrigated land, can satisfy the subnational crop area. The same is true for the agricultural land, and so we do for the suitable areas and for some more data. This together is a pre-process which creates the priors, which then feed into spam. As an example, here is Ghana, and in my example I took rice. This is the harvested area per region in Ghana. Just pulling out this northern region in Ghana, we take the irrigated area and combine it with the harvested area we have. You see, irrigated area is much sparser than the total area which is reported for this province. Then we have the agricultural area in that admin unit, further the rural population, the suitable irrigated area for rice, the rain-fed high inputs area for rice, the low inputs, and after we do the spam allocation, we receive the results for allocated irrigated area for rice, which is actually in its pattern quite similar to the irrigated area there, and that makes sense. We look, for example, as a result, the rain-fed, allocated rain-fed high inputs area for rice, and this in its pattern is quite similar to the agland we find in that area. And so it goes for the rain-fed low input area for rice, for the subsistence area in rice, and in subsistence the rural population density is the major factor to calculate it, and we see that it bears quite some similarity here to the population density. So if we take the total combination of all the production systems, we have the allocated area of rice in this, in this district is much more finer tuned than what the statistics tell us, that there are, I can't read this now, 47,000 hectares of rice. And a very important layer, which I have not mentioned before, is the FAO country totals, because all the calculations which are done are finally, at the very end, scaled to FAO country totals. This is mainly done to allow us aggregation of countries or regions into larger areas in a consistent way. SPAM results are, among others, maps, and they can be global maps or country maps or sub-national maps. In this example, it's the crop distribution of maize for the year 2005, which is harvested area of maize hectare per pixel, and this is one of the possible outputs. Another output are, for example, vegetables in the year 2005, the harvested area of vegetables hectare per pixel. The equations behind SPAM, if you look very carefully, they are written in a very faint gray in the background. But to summarize in a non-formulaic way, is to minimize difference between prior and allocated area share for all pixels, crops, and production systems. We use a cross-entropy equation, which is subject to constraints dictated by existing agricultural land, irrigated land, suitable areas, and crop area statistics. And all this is solved in GAMS. Before that can be done, we have to construct the priors for each pixel, for each crop and production system as a function of potential revenue, irrigated area, and agricultural land. And potential revenue in itself is then a function of percentage of crop area, crop price, rural population density, and potential yield. So you can see, before we can do the very top, we have to do a lot of operations at the bottom, and they take a lot of number churning and adjustments and calibrations before this can take place. SPAM, in its original, or the first version was SPAM 2000 with 20 crops. Now we have SPAM 2005 with 42 crops, of which a lot are fairly disaggregated, and they are grouped here in the cereals and the roots and tubers. Here it's a bit more aggregated and tropical fruit, temperate vegetables, and the rest is what is left after you take away the whole lot, and it accounts only between 2 and 5% of the global crop harvested area, with a few exceptions. And the rest, of course, in some countries is like rubber or spices or other olive crops, and tree crops. That's also part of the rest. I have 1 minute left. This is how the SPAM input data is available at subnational level, level 1 and level 2. You can see it all outside on the poster, I think, so I can rush through this. The challenges, there are different sources, and therefore you may end up with contradictory information. Raster data is not always at the same scale. Subnational data may be complete or not at different levels. We have to make sure that the national crop data conforms with FAO data. The consistency between layers, although they are all at the same level and they may, the same resolution and may come from the similar source, still may be inconsistent. The cropping intensity and production system shares are something very, very difficult to find and document properly for each country. And the validation of results. And for this, we hope to be using, among others, Geoshare to see how users react to using spam on Geoshare and giving us feedback. The opportunities are driven, of course, by the applications and the user preferences. And one opportunity is to move spam out of the enclosure of the hugging of IFPRI and making available to the much larger community. You can also include data at larger scale. Right now we have roughly a 10 by 10 kilometer. If you have better resolution for your ag land, for example, or for irrigation, then that can be incorporated into the model at HubZero. You can use more recent data, more recent statistics than the one centered around 2005. You can provide national prices or even subnational prices to construct your priors. You can expand or reduce your crop list, which is, of course, has an impact on the suitability of these crops and the suitability layer. You can construct your own suitability conditions, and that was done in the example which is going to be presented now by Jing Yu. Paul. The HubZero should allow us to reproduce the results each time. And it's also a good teaching tool on the one hand side for GIS and the use of GAMS. And hopefully it will be easier to validate the results, especially if it is run at a larger scale, where you can pinpoint areas and having a user feedback, some interface where the user can provide feedback in pointing out which areas have been allocated properly and which not. And this is all. Thank you very much.